Oh yes, level 27 unlocked. Oh, and an ad. Time to get some free coins. Oh, darn, lost again. What? Another ad? I'm so done with this game. Oh yeah, hey George, how's it going? Nothing much, just playing this dumb game. Could this situation have been avoided? If only there was a way to figure out that sweet spot, where you're showing just enough ads to generate more app revenue, but not so many ads that it impacts your user happiness. Wait a minute, there is a way we can do that. We can figure this out by running an ad frequency experiment. Let's get started. Okay, so let's talk about testing different ad frequencies. See, there's a setting you can use for ad units you create using AdMob, like interstitial ad units or rewarded ad units, that allow you to set how many times a user will see an ad over some given amount of time. So for example, if you're showing a video ad, you can determine how often you'd like to show that ad to your users by setting frequencies like once every 5 minutes, 3 times every 20 minutes, or 5 times every hour. Well, much like the story of Goldilocks and the Three Bears, there's probably one bowl of porridge that is too cold, one bowl of porridge that is too hot, and another bowl of porridge that is just right. Except, replace bowls of porridge with ad frequencies. Now in Goldilocks' case, she was able to find the perfect temperature porridge and the perfect size bed by just trying them out herself. For figuring out which ad frequency works best for your users, though, we'll need a much more sophisticated approach. What we'll need is to design an ad experiment. So if you recall from the first episode in the series, we'll need to use an experimentation methodology and a framework for all the ad experiments we're going to solve in this show. If you haven't watched the first episode before, check it out. It covers a lot of the groundwork that we're going to use for each experiment we solve in each episode. The link is in the description. In terms of the type of ad we're going to use, in this experiment, we'll use a rewarded ad because they're really easy to work with and work really well for this kind of experiment. As a matter of fact, if you're planning to test ad frequency for a game, you're probably already using a rewarded ad. If you haven't implemented one in your app yet, check out the link in the description, but feel free to go back to that later. Now, the experimentation methodology we're going to use is A/B testing. The first thing we'll need to figure out for this A/B test is which users we're going to target. You might be asking yourself, well, aren't we just going to target our whole user base and figure out which ad frequency works best for everyone? And the answer is no, we're not going to do that. Although having a lot more test data can help A/B testing generate more statistically significant results, there are many reasons why we want to be much more specific about our target test group. For one, if any of the ad frequency variants we're going to test leads to a worse user experience, we'll want to limit the scope of that impact to only a portion of our users, rather than expose a large number of our users to the same experience before we can evaluate it. Secondly, we may want to segment our A/B tests across different user segments and use different sets of variants for those different user segments. For example, it could be reasonable to assume that players in a game who play for 3 hours a day or more have a higher tolerance for viewing ads than, say, someone who just started playing the game or those who play for less than an hour per day. For the more active group, we might want to create an entirely separate A/B test using variants with higher overall ad frequencies than our less active group. And we might be even smarter about testing out the optimal frequency values for each of these groups. But for now, let's just say we want to run an A/B test among a random 10% of our users. For your own app, you'll want to choose a target group that is specific enough to include the most relevant user segments, as well as limit any potential impact of the test, but that is large enough to provide A/B testing with enough data to return a statistically meaningful result. So for a randomly selected 10% of our users, we're going to try different ad frequencies with the goal of, well, what is our goal? The most obvious answer is to increase our ad revenue. But if that's the case, isn't it obvious that the more we show ads, the more ad revenue we'll get? Well, not necessarily. See, if we show more ads, there's a possibility that will negatively impact our user retention rates, and less users means less ad revenue. So it seems fair to use increasing our ad revenue as the goal here, but there are also secondary metrics we'll need to consider, like the impact on user retention. Okay, so with our design experiment stencil filled out, let's go into the Firebase console now to set up the experiment. Okay, so in the Firebase console, I'll scroll down to the A-B testing section and click on it to start creating my experiment. Once it opens up, I'll click on Create Experiment and Remote Config, since we'll be using that to run the experiment in our app. For the experiment name, I'll enter Add Frequency Experiment and hit Next. Now I can select the app I want to target. If you have multiple apps like an Android app, an iOS, or a Unity game on both platforms, you'll need to create a separate experiment for each app platform. For now, let's just say I'm going to create it for my Android app, so I'll select my Android app here and set my user exposure level to 10%. By the way, here is where we can also apply segmentation of the test for different user groups too. I can add an additional targeting condition by clicking on and selecting from my Google Analytics user audiences and selecting, for example, my highly engaged user segment. And then for that group, I could use a higher base threshold for ad frequencies. But that's something we'll come back to later. Now I'll hit next, and I can select the goals for the experiment. First, let's start with the primary metric. There are a bunch to choose from, including some custom conversion events from Google Analytics, but let's stick with what we decided earlier and set estimated ad mob revenue as the primary metric. This means that whichever variant leads to more ad revenue, if any, will be declared the winner. But there are also secondary metrics we need to track. The defaults that are already added on will both be good to have. We want to make sure we're not negatively impacting our user retention, and tracking crash-free users is always a good idea for any self-respecting A/B tests. We want to make sure that none of our variants cause an increase in users crashing, even though in this specific case of an ad frequency test, it's less likely that a variant group of users will experience more crashes than the control. There are other additional metrics we can select to track here, but this set is good for now. So let's hit next. Finally, we're presented with the screen where we can set up the different ad frequency variants by creating some remote config parameters. But what should we actually parameterize here? So probably the most obvious answer is to parameterize the ad frequency values we want to use for each of our different variants. Maybe something like a parameter named ad frequency that represents how often an ad is shown to a user per hour. But while this is certainly doable, implementing this can get pretty difficult pretty fast. Let me show you what I mean. So if you've implemented an AdMob ad in your app already, your code to implement that will look a little something like this. I'll cover how to retrieve remote config parameters soon, but let's assume for now I'm already using the ad frequency parameter, which will have one of the values of our control or variant groups. Well, in order to use that ad frequency parameter as it's designed now, I'll need to add a counter to keep track of how many times my user was shown an ad. Then I'll need to check that against the ad frequency parameter to make sure I haven't surpassed the limit before showing an ad again. Okay, maybe that's not too bad so far, but then since my ad frequency limits are set on an hourly basis, I'll have to reset that counter every hour too. So I'll need a way to figure out how to do that. I could use a cache expiration policy, but that's an extra step that I'll need to implement, and also a step that varies per platform. And what happens if I want to use other ad frequencies that don't use an hourly basis, like showing an ad every 8 minutes? Somehow using the value 7.5 ads per hour feels a bit awkward. So yeah, this can get pretty complicated pretty fast. Don't get me wrong, this method does allow for a lot of control over the ad viewing experience, and if your app needs that, you can use this approach to implement your ad frequency experiment. But if all you really care about is an easy way to adjust and test different ad frequencies, AdMob provides a really easy way to configure that using the ad unit settings so that you can create and parameterize different ad units with different ad frequencies using those ad unit IDs. Let me show you what I mean. So in the AdMob console, I can head over to my app and see the first ad unit I created for the very first ad I've included in my app. Now it currently doesn't have a frequency cap defined, but I'll go ahead and set that now. For this one, I'll set it to show no more than one impression every 5 minutes. Then I'll hit save, and I'm done with that one. Next, I'll create a second rewarded ad with a slightly lower frequency cap and set it to show no more than 3 impressions every 20 minutes. And finally, I'll create a third rewarded ad with the lowest frequency cap of all my variants and set its frequency cap to show no more than 5 impressions every hour. Note that the ad units I just created each have different ad unit IDs, and each ID is a handle to the different frequencies I configure for each of them too. Now, rather than parameterize the ad frequency values directly in my remote config parameters, I can parameterize the ad unit IDs instead. No need for caching any special counters or setting any cache expirations. I have all my frequency settings configured here, and I can change them or add more ad frequency variants as I wish. Going back to designing our experiment in the Firebase console, I'll create a new parameter for the control group called addUnitID. And for the baseline value, I'll use the addUnitID for the first rewarded ad I configured. For variant A, I'll use the addUnitID for the second rewarded ad, and for variant B, I'll use the addUnitID for the last rewarded ad. Then I'll click on Review, and my experiment is ready to be started. Now at this point, I can start my experiment if I want, but nothing will actually happen until I implement the experiment in my app. So let's move on to that segment of the episode. Okay, so we'll need to implement and use those remote config parameters we just created in our application code. Now, if you recall from episode number 1, remote config parameters are essentially just key value pairs that live in the cloud, and they get pulled by your application code to get any new values that apply for that end user. So the first thing we'll need to do is initialize remote config and configure it to fetch new values from the remote config servers. So for Android, this would look like this. First, we get the remote config instance, then use the remote config settings builder to build and configure our settings, and then set them. Note that this call is asynchronous, so to be safe, it'll probably be a good idea to add a completion handler to check out that it completed successfully. I'll show you an example of that in the code snippet for Unity in a bit. Now, the minimum fetch interval is how often remote config should check for new values from the RC servers and invalidate and replace any local values that have changed. By default, the fetch interval is 12 hours, which is what I set here explicitly as well. I just wanted to illustrate what it looks like in case you want to set a different time span. For this experiment though, once every 12 hours should be fine. Next, we'll need to make the call to fetch and activate the remote config parameter values to retrieve them from the RC servers and activate them for use in our app. So we've got the fetch and activate call here, and then we add a completion listener which checks that we were successfully able to fetch and update the remote config parameters. If we were, that would be the right time to load the appropriate add unit. We'll get back to that function in a moment. The code to do this on iOS looks very similar. First, we retrieve the remote config instance, then create our remote config settings object to set the minimum fetch interval, and finally set the whole RC settings object back to our remote config instance. Next, we'll need to fetch and activate the remote config parameter values. So first, we'll make the fetch call, and if that call succeeds, make the follow-up call to activate the fetched remote config parameter values in our app. And if all that goes well, it's time to load the add unit based on the retrieved add unit parameter in this app instance. For the Unity SDK, the setup looks just a tiny bit different. So you'll get a remote config instance and create a config settings object in a similar way, but the first difference is that here, setting the minimum fetch interval requires passing a ulong representing the total time in milliseconds. And I'm using a time span here to make that a bit more readable. The second difference is that setting the config settings object is an async operation in Unity, similar to in Android, so we're adding a continue with on main thread callback here to verify that setting the config was successful. And now we can make the call to fetch and activate the remote config parameter values, so that's as simple as just making the call, adding a continuation to handle the result, and seeing if that was successful. After fetching the remote config parameter values, we can now load the add unit with the retrieved add unit ID parameter. At this point, we are set up to fetch any pending remote config parameter values from the RC servers, including the add unit ID parameter. Now we just need to finish the final piece, which is actually using the add unit ID parameter to load up the different add frequency variants. On Android, that call looks a little something like this. On iOS, it looks like this. And for Unity, it would be code in the lower box right here. Essentially, this call just gets the value of the add unit ID for this app instance, which will be one of the variants we configured earlier. And now we just got to use that add unit ID remote config parameter when loading up the ad for the user. I won't get into all the details for how to do the ad loading part because it's beautifully explained right in the AdMob guides on implementing ads in your app. The links to do that are in the description. In this episode, we were setting up rewarded ads, so the links point to that guide, but you can easily apply it to other ad types. Just follow the right guide. It's super easy. I promise. To show a quick example though, this is what the call might look like if you're loading the ad in an Android app, passing the ad unit ID remote config parameter when loading the ad. Okay, at this point, the app is fully wired up to run our ad frequency experiment. Can you guess what the next step is from here? That's right, we need to test out the implementation. Now that we have the remote config calls and AdMob calls in place in our app, everywhere we want to show some ads, we should test and make sure that the ads show up as we expect. So the easiest way to test this out is to use the dedicated test ad unit provided by AdMob for a test rewarded ad. This displays a simple ad that looks a little something like this and can be used to make sure the ad is showing up correctly. There is one test ad unit ID for Android and another for iOS, and each can be used for Unity games as well. You can find the ad unit ID in the AdMob implementation guides for rewarded ads. During testing, you can set each of the A/B testing control and variant values to this test ad unit ID to ensure the ID is being retrieved from remote config and the ad is being displayed correctly in each variant. Oh, and one more thing you'll want to do during testing is to set the remote config minimum fetch interval to 0 seconds. This means that every remote config call will always get the latest values from the remote config servers, which is helpful when you're testing things out and don't want to wait to try out different values. After you're satisfied with your testing, you can set the variant values back to the actual ad unit IDs and change the remote config fetch interval back to every 12 hours and deploy your app with this new code. Once it gets into the hands of your users, it's just a matter of time before we can start analyzing some test results. So obviously the whole point of testing and experimenting with A/B tests is that we don't really know what's going to happen, and if one of the variants will really be better than any others. So I'm going to walk through some simulated results here. If you're able to run A/B tests and predict the exact results before you run them, give me a call. But for now, let's take a look at what test results for your ad frequency experiment may look like. So it'll take a few days and maybe even weeks to collect enough test data in order to generate results with a strong enough statistical significance to determine if there is a winning variant. If and until that happens though, you can always come back to the running experiment in the console to see how things are going. So looking at the overview, I can see that the baseline, which is showing an ad every 5 minutes, is currently performing best out of all the variants based on the primary goal of optimizing our AdMob revenue. Looking at the experiment results, I can see that the graph further bears that out, as the baseline is indeed outperforming the other variants, but not by very much, and also not with much certainty. How can I tell that? Well, by looking at the shaded areas in the graph. So each line in the graph represents the observed data for each variant and the control, with a different color representing each of them. The shaded areas represents the uncertainty in that data. So the greater the overlap between areas of different variants, the less certainty that one is better than the other. Let's take a look at an example where there is a clear winner. So here we can see that the lines and the shaded areas for the performance of both variants is fairly distinct, and one of them is definitely outperforming all others. Looking further below at the breakdown of the observed and modeled data, we can see that indicated here as well. But that isn't the only thing that's important, since we're also tracking user retention and crash-free users as additional metrics. So we can tab through those sections too to make sure that even if a variant is outperforming others based on revenue performance, it isn't leading to significantly less users or to more crashes. Or better yet, it even improves upon them. The data for each of these secondary metrics is also broken down in the observed data and modeled data below. Once we're satisfied that we found a winning variant, with no drawback on user retention nor crash-free users, we can roll that out as the new control by clicking on the Rollout Variant button. This will roll out the value used in the winning variant to all users targeted in the same experiment. That is that 10% that we set up earlier. If you want to roll out the winning ad frequency to all users globally though, you can just end this experiment and set the value of the ad unit ID of the winning variant as the new default value for your ad unit ID parameter. This will ensure that all users will get the same ad frequency when using your app. And that's it. If you followed all the steps to this point, you'll have ad frequency experimentation implemented in your app, and you're ready to optimize your app revenue. So what do you think? Let us know in the comments. Did you try this experiment in your app? Did you manage to optimize your ad revenue? Did your users send you flaming negative reviews because of too many ads? Well, maybe just send us a private message in that case instead of posting in the comments. Just kidding. Please do post in the comments. Let us know either way because we'd love to get your feedback. That's it for this episode, but tune in for the next one where we explore the question, should I show ads in my app in the first place? This will be an excellent resource for those of you who haven't included ads in your app yet, but would like to do so without impacting your user experience. Until then, be sure to like, subscribe, and share this video, and I'll see you in the next episode.